Hello everyone. So today's session we will discuss about what is Poisson's ratio. It is denoted by the letter sigma. So when two equal and opposite forces are applied to a body along a certain direction, the body extends along that direction. So you can see when uh, this is one of the body. So I am applying some forces to the lengthwise direction. Okay, some forces on this direction and this direction. Okay, what will happen? The body will extend to, or if it's a rubber band, what will happen? It will the length is there is some longitudinal change in the size. Okay, so this will extend to like this. The body will change to like this. Okay, so you can see there will be some changes in the lengthwise direction where we applied the forces, and you can see there will be some compression in the perpendicular direction. So here there is some compression will happen. So it is called extension in the longitudinal direction, and there is compression in the perpendicular direction. Okay. So this is the fractional change in the length in the direction along which the forces have been applied is called the longitudinal strain. So we can say the change in length by original length in the longitudinal direction, we will call it as longitudinal strain. And similarly, the fractional change in the perpendicular direction is called lateral strain. Okay, so there will be two terms coming, longitudinal strain and lateral strain. So this is the fractional change in the longitudinal direction, and this will be the fractional change in the perpendicular direction. Okay, so within the elastic limit, the lateral strain is proportional to longitudinal strain. That is, the ratio of lateral strain and the longitudinal strain is a constant for a particular material. Okay, so this constant is known as Poisson's ratio. So Poisson's ratio will be the ratio of lateral strain to longitudinal strain. So that we can write it as lateral strain to longitudinal strain. Lateral strain to longitudinal strain. Okay. So this lateral strain will be expressed in the terms of beta, and longitudinal in the term of alpha. Okay. So this is the expression for Poisson's ratio, sigma equal to beta by alpha. Consider a wire of length capital L and diameter capital D. Let the length of the wire be increased by small l. Let the length of the wire be increased by small l under the action of two equal and opposite forces two equal and opposite forces, that is this direction and this direction. Okay, two equal and opposite forces, and d be the corresponding decrease in diameter, corresponding decrease in diameter. Okay, so now we will calculate what is alpha and beta in terms of L and T. Okay, diameter. Then we can say longitudinal strain. So longitudinal strain, all of you know, it will be the change in length divided by original length. So longitudinal strain equal to, that is expressed in terms of alpha, that will be small l divided by capital L, and lateral strain is beta, that is change in diameter by original diameter, so d by d. So therefore Poisson's ratio sigma equal to beta by alpha, which will be equal to L, okay, d by d and L by L. Okay, this is the final equation. So in differential form we can write it as sigma equal to L by D. Here the length will be the original length and the original diameter will be kept it as constants, L by D, and which will be equal to dt by dl. This is the differential format. Okay, so Poisson's ratio is a pure number and has no units and dimensions. Okay, there is no unit, it's a ratio, so there is no unit for Poisson's ratio. Poisson's ratio is a pure number. And has no units and dimensions. Okay, we can find the theoretical limiting values of Poisson's ratio. That will be obtained by using the equation which will related with the Young's modulus, bulk modulus and the Poisson's ratio, and also with the rigidity modulus. So we can find out the theoretical limiting values for Poisson's ratio. So next is theoretical limiting values of Poisson's ratio. Okay, so we have the relation between Young's modulus, bulk modulus and Poisson's ratio, that is y equal to 3k into 1 minus 2 sigma, and the another equation with the Young's modulus and rigidity modulus is y equal to 2n 1 plus sigma. This is the another equation. Okay, so there is two equations. The derivation of these equations will be taken in the next class. So y equal to 3k into 1 minus 2 sigma, y equal to 2n into 1 plus sigma. So this equation is same for both, same for Young's modulus. So we can equate these equations. So we can write it as 3k 1 minus 2 sigma will be equal to 2n 1 plus sigma. So if sigma is that is Poisson's ratio is positive, what will happen? The right hand side is positive, therefore left hand side must be positive. This is only when happen. So the first condition is if sigma is positive. Sigma positive, then right hand side is positive, that therefore left hand side must be positive. Left hand side must be positive. Okay, this is happen only when this term 1 minus 2 sigma become positive. That is 1 minus 2 sigma is greater than 0. Okay, this is happen only when this one will be become greater than 0, that is positive. So we can say 1 is greater than 2 sigma. So we can say 1 by 2 greater than sigma. That means that is sigma is less than 1 by 2 or sigma is less than 0.5. Okay, so from this we got the value for limiting, one of the limiting value for sigma is 0.5. Next, what will happen if the sigma is negative? So on the other hand, if sigma is negative, the left hand side is positive, you can see in the above equation 3k into 1 minus 2 sigma. If sigma is negative, this term will become positive. So LHS is positive. That means right hand side must be positive, and then RHS must be positive. Okay, so this is happen only when when 1 plus sigma, that is the term on the right hand side, 1 plus sigma is greater than 0. That means sigma is greater than minus 1. Okay, so the theoretical value, that is the theoretical value of sigma, the theoretical value of sigma lies between the two values, that is minus 1 and 0.5. So but then practically we obtain that this is the theoretical value, but by finding using many materials, we find out the Poisson's ratio, but we obtain in practically the values range between 0.2 to 0.4. So the practical value practical value of sigma is lies between 0.2 and 0.2 to 0.4. Okay, so this is the theoretical values -1 to 0.5. Okay, now we will do some problems based on Poisson's ratio. So problem 1. Assuming the limiting value of Poisson's ratio to be 0 and 0.5 and 0.5. Prove that y of a material cannot be greater than 3 times its modulus of greater than its modulus of rigidity. Okay, so here the condition is given that the limiting value for sigma is in between 0 and 0.5. So we have value of sigma will be in between 0 and 0.5. Okay, so using equation y equal to 2n 1 plus sigma, we can write equation for sigma will be y by 2n minus 1, and we can write this in between sigma with the range, the value for this value will be in between 0 and 0.5. So we can write zero in between y by 2n minus 1.5, and this also we can write y by 2n 1 plus 0.5, and this value also we can take outside. So 2n y 1.5 here, this 2n will take to 2 sides, so 1 plus 0.5 will be 1.5 into 2, it will be 3n. Okay, and the y value is between 2n to 3n. So we already proved that in the question it is say the Young's modulus of a material cannot be greater than 3 times its modulus of rigidity. So the value is in between 2n and 3n, so it's not more than 3n. So this means that the Young's modulus cannot be greater than 3 times the modulus of rigidity. Hence we proved. Okay, hence we proved. Next problem. Calculate Poisson's ratio of steel, material given here is steel, given that y equal to 2 into 10 to the power 11 Newton meter raised to minus 2, and relative modulus is n equal to 8 into 10 to raised to power 10 raised to 10 Newton meter raised to minus 2. So we can get the equation Poisson's ratio. So from the equation y equal to 2n 1 plus sigma, we will get the equation for sigma is y by 2n minus 1, and here the value for y and n is given, so we can write it here. 2 into 10 raised to 11 divided by 2 into 8 into 10 raised to 10 minus 1, and that will be equal to 1.25 minus 1, that is 0.25. So this is the value for sigma. Thank you.